Okay, in this video I want to talk about, I want to review linear functions from Algebra 1. And if you remember from Algebra 1, you had functions that looked like y equals x plus 2, or y equals 2x minus 5, y equals negative 3x plus 4. Basically, it was always in the form y equals mx plus b. Okay, so that was Algebra 1. You were talking about linear functions. And so the graphs kind of look like, you know, from what you remember, you could start here at 2. That's your y-intercept, and you have a slope of 1. So it kind of looks like this. These are just rough sketches. This one starts at negative 5. It has a slope of 2, so it's a little steeper than the other one. This one starts at 4 and has a negative slope, negative steep slope, so it kind of looks like this. These are just rough sketches. So the B represents your y-intercept, and the M is your slope. And then you have this function y equals x, and this one here is what we call the parent function. Parent function, meaning that all these other functions are just what we call transformations. Transformations of that parent function. In other words, if you sketch the graph of this one, y equals x squared, it looks like this. Perfect diagonal. Another way to think of y equals x is y equals 1x plus 0. So you have your mx plus b, except your b is 0, which is right here, and your slope is 1. So you're going up 1 over 1, up 1 over 1. And it looks just like this. You're adding nothing to it. So 1x plus 0 is the same as just saying 1x, and 1 times x is just x. So this is the same thing as this, just if you wanted to see it in the form y equals mx plus b. So this is your parent function, and these each are just a transformation of that, meaning take that parent function, and if you add 2, all you're doing is shifting it up 2 units. It has the same slope of 1, just like this one does, only it's shifted 2 units up. So it looks exactly the same, just 2 units higher. That's a transformation. This one is shifted 5 units down, and it's a little steeper than the original one. So not only did this slide down 5 units, it sort of shifted up a little bit like that. So that's why it looks steep, because of the slope is a little steeper. And this one, of course, shifted 4 units up, and then it has a negative slope. So it went from up, and then it rotated to a negative and a kind of a steep slope, negative 3. Okay, so those are transformations to the parent function. And these are concepts you're going to need going forward, because I want to start talking about what we call quadratic functions. So this is my introduction to this concept. Quadratic function. So it's a new type of function. It has a different look to it. These are all linear meaning line. And that's why all the graphs come out to be a straight line. And remember, the graphs are just representations of the solutions. If you wanted to see the solutions to this, you would make a table, and you would just plug in values. Instead of starting, this is a shortcut when you start with y equals mx plus b, you're starting with the intercept, and you're just kind of going up and over. But that's a shortcut to graphing the solutions. The solutions are when you say, okay, if x is 0, 0 plus 2 is 2. If x is 1, 1 plus 2 is 3. If x is 2, 2 plus 2 is 4. And then you start to see a pattern in your answers, and you go, wait a minute, 0, 1, 2, 3, 4, 2, 3, 4, 5, 6, and so on. And then you graph them by going 0, 2, 1, 3, 2, 4. Okay, so this is the long way of doing it, but this is what the graph represents, is all the solutions to this function. Okay, this is a visual representation of this solution set, and there are infinitely many solutions to this. Right, this list goes on forever, and that's why we have arrows at the end of our graphs. So I want to take all these concepts you learned in Algebra 1, and I want to apply them to a new type of function for you called quadratic functions. And just to give you a little sneak preview, quadratic functions can look like, I'm just gonna give you a bunch of, and we'll get to all of this. That's a quadratic function. This is a quadratic function. This is a quadratic function. Another, and slightly more complicated, I guess. That's a quadratic function. And what do they all have in common? It's this exponent of 2, and you don't have that in a linear function. Okay? And the parent function of all these, meaning when I say parent function, I mean the most simple type of example. This is the most simple type of example of a linear function as compared to these, which look a little more complicated because you've got an intercept here and a different slope. Okay? So the most basic, simple, what I call a parent function of all the quadratic functions is y equals x squared. Okay, and this is where our story begins. So we're going to start looking at quadratic functions, and we're going to begin with the parent function, and then eventually we'll have an understanding of what these graphs look like as a transformation of this original parent function.